the first law is that universal energy is constant, neither created nor destroyed. So we've drawn the universe as a circle, and everything inside the circle is in the universe, and everything outside the circle is not. I've populated this universe with all different kinds of energy, including masses. I mean, we can think of the universe as composed of galaxies and planets and moons and suns, or we can simply think of the universe as filled with all different kinds of energy, including energy as mass. Watch what happens when I animate this illustration. First, look at the energy that is mass and light, shown in green. You will see that mass and light are being converted to chemical energy and heat energy. That is called energy transduction. The other forms of energy, shown in orange, I guess that color is, have simply moved about, representing that energy can be transferred from one component to another in the universe without necessarily being converted from one kind to another. So to summarize, energy and mass in the universe can be transferred between systems in the universe, between components, or energy can be transduced, changed from one kind to another. But you'll notice that no energy shown as being in the universe has left or escaped the universe, and there was no entry of energy from outside the universe into it. That is what the first law means. Universal energy is constant. The universe has a certain amount of energy distributed in all these different kinds, and that is constantly in flux. But that number, that amount of energy, which of course we cannot determine, is a constant. These properties I've just described are the properties of any closed system, and the universe then, by this criterion, is a closed system. The second law of thermodynamics says this thing called entropy is always increasing in the universe. Entropy is often described as disorder or chaos or randomness. I'll introduce a few other terms to help us imagine what entropy is. Here's another example of how order increases locally, but at the expense of creating disorder elsewhere. This is a hydroelectric dam. The water in the lake has potential energy. The potential energy of this water will be transduced to electrical energy as it flows through the dam, but with increased entropy. That is, the water will experience an increased disorderly random motion as it flows through the dam, so that down in the stream bed the water will be in much greater motion than it was at the top of the dam. The water at the bottom of the dam, I think we would all agree, is less potentially useful than the water above the dam. Another way to look at this is to say that the water in the stream bed below the dam is more useless, or by comparison to the potentially useful water in the lake, the water that has already flowed through the dam is now useless. So entropy then can be seen as useless energy, energy that can't be used to do anything productive, unlike the water in the lake. Well, if entropy, or this disorderliness or randomness, is in fact useless energy, then all kinds of energy can be grouped into just two kinds: useless and its opposite, useful. So here I've drawn the universe again, and I've simply said that all kinds of energy that I had in the previous universe are useful kinds, and there's a certain amount of randomness or entropy already in the universe, so I've populated the universe with some useless energy as well. When I animate this picture, you will see events that are consistent with the first law of thermodynamics, but that also obey the second law. And there they are. Useless energy has increased at the expense of useful energy, and this is indeed consistent with the first law, because you'll see that neither useful nor useless energy has left the universe nor come into the universe. And though it's not stated on the slide, it is not only consistent with the first law, but also with the second law saying that universal entropy always increases.